Hello and welcome back to the channel. In this course, we're going to have a deep dive into a beginner's guide to object-oriented programming in Java. Before we get started, don't forget to like the video and subscribe to the channel for more programming content. In this video, we're going to be setting up our environment, which includes installing Java and a text editor that we're going to be using to write our code. We'll also look at some concepts to introduce you to object-oriented programming. The first concept we need to look at is defining object-oriented programming. Object-oriented programming is a way of organizing our code, and it revolves around the concept of objects and classes. So these objects and classes are used to represent things that exist in the real world. For example, if we wanted to represent a house in our code, we would create a class called house, which is going to act as a blueprint. This means that using this class, we can create different houses, and the houses that we create are going to be called objects. There are different programming languages that support object-oriented programming. In this course, we're going to be using Java. However, the concepts we see throughout this video can be applied to other programming languages. There are 3 editions of Java: the Standard, Enterprise, and Micro edition. The Enterprise edition is used for developing large-scale Java applications, and the Micro edition is used for mobile and embedded devices. However, in this course, we're going to be using the Standard edition, which is used for general-purpose programming. Now, to install Java, we're going to open up our browser and head to the following link. You can find the link in the description below. Once the page has loaded up, we're going to scroll down. And here we can see that the latest version of JDK is 22.0.2. And based on our operating system, we're going to choose a download link. Now, since I already have the JDK installed, I'm not going to download it again. But all you have to do is follow the steps inside the installation wizard. Once the installation is finished, we need to verify that Java has been added to the path. Adding Java to the path is going to let us use the JDK from anywhere in our system. Now, to verify that, we're going to open our environment variables. To do that, we're going to open the Start menu and we're going to search for environment. And we're going to edit the system environment variables. From here, we're going to choose environment variables. And under our system variables, we're going to search for path. And we're going to double click on it to open it. Now you need to make sure that some sort of Java path or JDK path is included inside your environment variables. During the installation process, if you used all the default locations, copy these to your environment variable. The final step is to verify that you've installed Java correctly and that you've added it to the path. To do that, we're going to open our command prompt. And in here, we're going to type Java C -- version and press enter. Now, if you get a version of Java C and you don't get any errors, that means you've correctly installed Java and added it to your path. You can also check for Java -- version. And as you can see, the version of Java gets displayed. As we previously saw, classes in Java are like blueprints to making objects. And when we install Java, we get the Java APIs. The Java APIs include pre-written classes, which we can use in our code to make our program more efficient and give us easy access to built-in functionalities. Later in this course, we're going to see what these APIs are. The next concept we're going to look at is the steps we go through when developing a Java program and running it. The first phase is edit. This is the step where we write our Java program and save our file using the .java extension. The second phase is compile. In this step, the compiler converts our code into something called bytecode. and the name of this file ends with the .class extension. The third phase is load. In this step, a program called the class loader reads our bytecode and puts it into our primary memory. The fourth phase is verify. In this step, a program called bytecode verifier makes sure that our bytecode is valid and passes Java's security restrictions. The final phase is execute. In this step, the Java virtual machine translates our bytecode into a language that our computer understands and our program executes. Now that we've installed JDK and seen the steps of developing a Java program, the final thing we need to decide is where we're going to write our code. We can write our Java program in a simple notepad and execute it using the command prompt. This, however, is going to have its drawbacks. Since Notepad doesn't have any error checking, solving bugs that arise in our code would be very difficult. Another drawback is the absence of code completion. This is going to make writing code a very slow process. Due to these drawbacks, we're going to be using an IDE, which is an integrated development environment. There are many IDEs you can choose from, like Eclipse, NetBeans, JBuilder, and BlueJ. For this course, however, we're going to be using Eclipse. To download Eclipse, we're going to head to the following link, which you can find in the description below, and we're going to scroll down and press on the download button. Since I already have Eclipse installed, I'm not going to install it again. If you have any questions regarding the installs we saw in this video, you can put them in the comments below. In this video, we're going to be writing our first Java program. We're going to open Eclipse, and the first step is going to be creating a project. So we're going to go to File, New, and we're going to pick Java Project. We're going to give our project a name. We're going to call it First Program, and we can change the location where we want our project to be stored. For this, I'm going to choose the default location, and we can press on Next, then Finish. Now, if we look at the left side, we can see that a new folder has been created, which is called First Program. And if we expand this folder, we can see that we have JRE System Library and SRC. The JRE System Library is going to contain the different Java APIs we talked about in the previous video. And the second folder, named SRC or Source, is where we're going to save our Java files. So we're going to head to Source and we're going to right click. Then we're going to go to New. And as we saw in the previous video, all the concepts we're going to be seeing are going to be related to classes and objects. So here we're going to be creating a new class. So we're going to pick Class. We can give our class a name. We're going to call it Hello World. There's a naming convention we should follow when naming our classes. This convention is starting each word with a capital letter. This means in our file name we have a capital H and a capital W. One more thing we need to do is head to public static void main, and we're going to click on the checkbox. And finally, we're going to click on Finish. Now, if we look at the left panel, we can see that in the source folder, we have something that says default package. We're going to look at packages later in this course. And inside the default package, we have our Java file. And in this file, we have some generated code that we're going to break down. When we look at the first line, we have the keyword public. This is what is called an access modifier, and its purpose is to decide the accessibility of our class. So if we set it to public, that means our class can be accessed by other classes. And if we set it to private, that means other classes cannot access components of our class. Then we have the keyword class. This is going to be used when we want to create our own class. And finally, we have Hello World, which is the name of our class. Here you may have noticed that the name of our class and the name of our Java file is the same. There are rules that we have to follow when naming our file. if we have more than one class in our file, we can only have one public class, and the name of that public class should match the name of our file. And if we don't have any public classes in our file, the name of the class that contains the main method should be the name of our file. Next, we're going to see what the main method is. Again, we have the keyword public. That means this method can be accessed by other classes. The keyword static means that an object does not need to be created in order to access this method. We're going to look at this keyword more in depth later in this course. Then we have the keyword void. This means that the main method does not return anything. Later, we're going to look at methods that do return. And in that case, we're going to have a data type instead of the word void. And finally, we have the method name, which is main. Methods are blocks of code that do a specific task, and these methods can take input. In the case of the main method, it takes in a string array as input. We're going to look at this in more depth when we learn about arrays in Java. One thing we have to note here is that the main method is a special type of method, and if we want our Java program to run, it must be included in this exact format in our class. When we go inside the main method, we have what is called a comment. Comments are notes that we add to our code that are ignored by the compiler. So they are notes that we keep for ourselves, or they're notes that we keep so other people reading our program can understand what our code does. In Java, we can have three types of comments. A single line comment like the one we have here. We can also have a multi-line comment. The difference is that a single line comment spans a single line and a multi-line comment spans multiple lines. Now to create a multi-line comment, we're going to have a slash followed by a star. Then we can have whatever text we want, and we end it by having a star followed by another slash. The third type of comment is a Java doc. A Java doc is a special type of comment that is used to generate documentation for our code. This documentation could include the purpose of different methods, the type of input they take, and what they return. So to define a Java doc, we're going to have a slash followed by two stars. And similar to multi-line comments, we can have whatever we want. And to end a Java doc, we're going to use a star followed by a slash. Now, the first functionality we're going to be looking at is how to display text to the terminal or console. So we're going to clear out the comments we created. And in our main method, we're going to type in system.out.println. And in parentheses, we're going to have double quotes. And we're going to put in hello, world. And finally, we're going to have a semicolon. When we break this line up, first we have system. This is a predefined class that we get when we install the JDK. And we know it's a class because of the naming convention it follows. As we said, classes have the first letter of each word capitalized. So since we have a capital S, we know that system is a class. Using the dot operator, we can access different components inside the system class. And the component we're accessing is out, which is a static field. We're going to see what static fields are when we define our own classes. For now, all we need to know is that out represents output. Next, we have println, which stands for print line. Println is a method. We know this because when calling or using methods, they are followed by parentheses, just like the main method. Finally, inside the parentheses, we put in a value that we want to get printed out. In our case, we have what is called a string. A string in Java is a sequence of characters that are stored inside double quotes. Using the println method, we can print out strings, numbers, and other data types. Finally, when we've finished writing our statement, we use a semicolon. We use semicolons when we want to end a single statement. Now, when it comes to running our code, if we were using a simple notepad, we would have to run a series of commands. So the first command would be javac, followed by the name of our file, which is hello, world.java. Now, if you remember the steps of executing a Java file, the javac is a compiler that is going to convert our file into bytecode. And to execute this bytecode, we need to run java followed by hello world. And if we press enter, nothing actually displays. That is because we haven't saved our file. So we're going to head back to Eclipse and save our file. Now, if we compile our file again, and if we execute our bytecode, we get hello world displayed to the terminal. However, if we're using an IDE, we can simply press on the run button to execute our code. We get hello world displayed. Now, if you're using Eclipse, you can use a shortcut. So for example, if we replace the text with Ethiopia, and if we save our file, you can run the file using the shortcut Ctrl plus F11, and your program will run. Another thing we can see here is the print statement instead of println. The difference between print and println is that when we're using println, whatever statements we have after are going to be on a new line, but when we use print, whatever statement we have after is going to be on the same line. So we can see this if we have another print statement. So we're going to say system.out.print, and we're going to print out an exclamation mark. Now if we save our file and if we run it, we see that the exclamation mark is displayed on the same line. Now if we had println instead, and if we ran our file again, we would have the exclamation mark on a new line. So that is the difference between print and println. Another type of printing we can have is using printf. When using printf, first we're going to provide a format that we want our output to follow, and we're going to give it arguments to substitute in that format. So we can have in double quotes %s, \n, which represents a new line. Then we're going to have another %s, a \n, %s, and a \n. So the %s is a placeholder for a string, so we can substitute in a string value. To do that, we're going to have a comma, and for the first %s, we're going to substitute welcome. For the second %s, we're going to substitute to, and for the third %s, we're going to substitute Java programming. And something we shouldn't forget is when we finish a single statement, we need to end it with a semicolon. Now, if we save our file and run our code, we get welcome to Java programming on separate lines. That is because we used the \n. And in this video, we're going to be seeing how we can take user input in Java. To see this, we're going to create a new class. So we're going to go to our package, and we're going to go to new, and we're going to pick class, and we're going to give our class a name. We're going to call it addition. And since we want a main method in our class, we're going to make sure public static void main is checked, and we're going to click on finish. When we want to make any program more dynamic, the first thing we need to consider is how to take user input. And in Java, to take user input, there's a class that we have to import. To import a class, we're going to be using the import keyword followed by the name of the class that we want to import. And when we import a class, we can use all the public methods or functionalities in that class in our own code. So here we're going to import java.util.scanner. Another thing we can see here is the concept of packages. Simply put, packages are folders that store Java classes. So when we say java.util.scanner, we're saying that inside the Java folder, there's a util folder and inside the util folder, we can find a class named scanner. So when we created our first program, we were given an option to provide a package name. So what that meant was in our project, a folder with the name we provide would be created, and in that folder, our Java file would have been stored. The usefulness of using packages is when we want to import our own classes. So if we don't provide a package, and if our class is in the default package, we won't be able to import our class from a different location. Now, once we've imported the scanner class, in order to use it, we need to create an object. As we said in the beginning, a class is a blueprint or a recipe. So to actually use it, we're going to have to create a scanner object. And to do that, first we're going to put in the name of the class, which is scanner. Then we're going to give our object a name. In this case, we're going to call it input. And we're going to set it equal to new. And we're going to have the class name again, which is scanner. And in parentheses, we're going to pass in system.in. And finally, to end our statement, we're going to add a semicolon. So here we have scanner, which is the class name. Then we give our object a name, which in this case, we gave it input. And we set it equal to new scanner. And in parentheses, we pass in system.in. Previously, we saw that system.out represents output, and the opposite, system.in, represents input. Now, using this object, we can access different functionalities related to taking input. Next, we're going to see what variables are. Variables are named containers that are used to store different types of values. In Java, we can store strings, numbers, or Boolean values. So to define a variable, first we're going to put in the type of data that variable is going to contain. Then we're going to give that variable a name. And optionally, we can also give it a value directly in the same line. So for example, if we wanted to create a variable called number1 that is going to store a data of type integer, we're going to say int. Then we're going to give the variable name, which is number1. And optionally, we can give it a value. So here, the value 10 is going to be stored in the variable number1. Now, giving it an initial value is optional. We can also leave number1 as it is. Other types of data we can store in a variable include string for storing string variables. One thing to note here is that string is going to be spelled with a capital S. We can also have Boolean values, which means this variable is going to store either true or false. We can also store decimal values using double or float. But for now, we're going to be using the int data type. So what we're going to do now is create an application that takes two numbers from the user, and it's going to display the sum of the two numbers. So we need two variables to store those numbers. We already have number1, so we're going to create another variable called number2. Next, we're going to prompt the user to enter a number. We can do that using system.out.print, and the prompt is going to be enter the first number. And next, we're going to use the object we created. Since we want to take in an integer input, we're going to use input.nextInt. And since it's a method, we need to have parentheses after the method name. Now, once we've taken the input, we want to store it in one of our variables. To do that, we're going to say number1 is equal to the input statement. So this is going to take in an integer input, and it's going to store it in the number1 variable. Now we need to do the same thing for the second number, so we're going to have system.out.print, and we're going to prompt the user to enter the second number. And again, we're going to use the input object, and since we want to take in an integer, we're going to use nextInt, and we're going to store that value in the number2 variable. Finally, if we want to store the sum in a variable, we can do that. So we're going to create another int variable and we're going to call it sum. And we're going to set sum equal to the sum of the two numbers. So we're going to have number 1 plus number 2. Finally, to display the sum, we're going to use a printf statement. So we're going to have system.out.printf. And first we need to provide our format. So our format is going to be the sum of the two numbers is followed by a placeholder. So we've seen the string placeholder, which is %s, and the placeholder for an integer value is going to be %d. And finally, we can add a new line. And for the arguments, we need to pass in an integer value. In our case, we're going to pass in sum. And finally, to finish off our statement, we're going to add a semicolon. Now we can save our file and we're going to run it. It's going to ask us to enter the first number. We're going to give it 3. It's going to ask us to enter the second number. We're going to give it 2. And when we press enter, it displays the sum of the two numbers is 5. So in this application, we took in an integer value, but if you want to take in other types of data, you can do that by accessing different methods. So for example, if you wanted to take in a double value, you would say next double, and this is going to take a double value from the user and it's going to store it somewhere. Now we're getting an error. That is because our number 1 variable is of type int, but if we change this to double, then our error disappears. In this video, we're going to be looking at conditional statements. When we want to make decisions in our code, we're going to use conditional statements. As in other programming languages, we can have conditional statements in Java. We're going to follow the same format. We're going to have the keyword if, and in parentheses, we're going to have a condition. And if that condition is true, then the statements in that block get executed. Else, they're going to get skipped. So to demonstrate this, we're going to be building a program that compares two values entered by the user. So we're going to create a new class. And we're going to call it comparison. We're going to make sure that we check the public static void main. And we're going to click on finish. Before we build the comparison application, we're going to look at the syntax to using conditional statements in Java. So let's say we have a number called num and we're going to set it equal to 10. And the syntax we have to follow is if, and in parentheses we're going to have a condition. For example, we can say if num is greater than 5, then we're going to have a block of code that is going to execute if this condition is true. So here we can print out the number is greater than 5. And now if we save our file and run our code, we get the number is greater than 5. Now if we change num to a number that is not greater than 5, let's say 1, and if we save our file and run our code, nothing gets displayed. That is because the if statement block gets skipped. Another thing we can do here is add an else block. So we're going to have else, and let's print out something else. We're going to print out the number is not greater than 5. Now if we save our file and if we run our code, we get the statement the number is not greater than 5. That means it's going to check the condition inside the if statement, and if that is not true, it's going to go to the else block. One more thing we can do is check multiple conditions. To do that, we're going to be using else if. So here we can have else if, and we can provide a second condition. Let's say num less than 5. Then we're going to print out the same thing. The number is not greater than 5. Now both conditions are going to be checked, and we can also have an else statement. And in here we're going to print out the number is equal to 5. So what's going to happen here is first the if condition gets checked. It's going to check if number is greater than 5. If that is not true, it's going to go to the second condition. It's going to check if number is less than 5. And finally, if both conditions are not true, whatever is inside the else statement gets executed. So if we save our file and run our code, we get the number is not greater than 5. Now if we change num to 5, save our file and run our code, we get the number is equal to 5. So this is how you use conditional statements in Java. Now we can go back to our comparison application. Since we're going to be taking user input, we need to import the scanner class. To do that, we're going to have import java.util.scanner. And in order to use the methods inside the scanner class, we're going to create an object of type scanner. We're going to give it a name. We're going to call it input, and we're going to set it equal to new scanner. Next, we're going to prepare variables that are going to store the user's input. We're going to be taking two numbers, so we're going to have int number 1 and int number 2. The next step is going to be prompting the user to enter a number. To do that, we're going to use system.out.print, and we're going to tell them to enter the first number. Then we're going to be using the input object, and we're going to be accessing the next int method, and we're going to be storing whatever the user inputs inside the number 1 variable. Next, we're going to do the same for the second number, so we're going to have system.out.print, and we're going to prompt the user to enter the second number. And again, we're going to use input.nextInt, and we're going to store that value inside the number 2 variable. Next, we're going to handle the different comparisons. So we're going to have if. The first comparison we're going to check is if number 1 is equal to number 2. To check for equality, we're going to be using two equal signs. And if this is true, we're going to system.out.printf. So printf is going to be printing out based on a format. The format is going to be %d is equal to %d. And inside the placeholders for %d, we're going to substitute number 1 and number 2. So this is the first condition. We're going to have another if statement, and this is going to check if number 1 is not equal to number 2. So to check for non-equality, we're going to be using the exclamation mark followed by an equal sign. And if this is the case, we're going to copy the previous statement, and we're going to paste it here, and we're going to change the equality to not equal. Next, we're going to check if number 1 is less than number 2. If that is the case, we're going to print out the same statement, and we're going to change the operation to less than. Next, we're going to check if number 1 is greater than number 2. And again, we're going to print out the same statement and change the operation. Next, we're going to check if number 1 is greater than or equal to number 2. If that is the case, we're going to print the statement out and change the operation. And finally, we're going to check if number 1 is less than or equal to number 2. And we're going to print out the statement and change the operation. Now here there is a reason that we did not use else if statements. That is because when we're using else if, only one of the blocks are going to execute. But in our case, we want more than one block to execute. For example, if we had 2 and 4, we would want the inequality to execute. We also want the less than to execute. And finally, we also want the less than or equal to execute. So if we want to execute more than one block, we have to use separate if statements. Now we can save our file and run the code. For the first number, we're going to put in 2. For the second number, we're going to put in 4. Now here, as you can see, the output is not readable. That is because we didn't use the new line character. So in each printf statement, we're going to add a new line to the end. Once we've added all the new lines, we can save our file and run the program again. For the first number, we're going to put in 2. For the second number, we're going to put in 4. And as you can see, we get 2 is not equal to 4. We get 2 is less than 4. And finally, we get 2 is less than or equal to 4. In this video, we're going to be looking at classes and objects in more depth. As we said before, classes are templates or blueprints used to create objects. So for example, the design of a car is a class, and the actual car that we make is an object. Other keywords that we need to know are instance variables and methods. If we use the car analogy, methods are the actions that a car can perform, like speeding up or braking. And instance variables are attributes that describe the car, like the color of the car or the model of the car. So in this section, we're going to be looking at how we can create our own classes and objects. To see this, we're going to create a new class. And we're going to call it Gradebook. And we're going to press on Finish. In the Gradebook class, we're going to define a method. So we're going to have public, which is going to be the access modifier of the method. Then we're going to have the return type of the method, which in our case is going to be void, which means it's not going to return anything. Then we're going to give our method a name. We're going to call it display message. And we're going to have an empty set of parentheses. This is because our method is not going to take any input. And we're going to have a block of code. In this method, we're going to be printing out a welcome message. So we're going to have system.out.println, and we're going to print out welcome to the gradebook. So to break this code down, we have a public class. As we said before, public means it can be accessed by other classes. And we've given our class a name, which is gradebook. One thing you need to remember here is that our public class's name should be the same as our Java file name. So in the gradebook class, we've defined a method called displayMessage, and its purpose is to display welcome to the gradebook in the terminal. When we break down the method declaration, again we have public. This means that other classes are able to access this method. Next we have void. As we said, this is the return type, and void means the absence of a return type. If our method did return a value, we would put the data type of that value instead of void. And next we have our method name, which is displayMessage. Again, there's a naming convention we should follow when we are defining our methods. This convention is that the first letter should be small, but every subsequent word should have a capital first letter. And finally, we have an empty parentheses. As we said, this is because our method does not take in any input. Later on, we're going to be looking at examples that do take input. And in that case, we would be putting the different inputs in the parentheses. Now, you may have noticed that in our class, we do not have a main method. And this means that we cannot directly run this class. So if we tried to run this, we would get an error. In this section, we're going to be defining our method in a different class. So we're going to save this file, and we're going to create a new class. And we're going to call it Gradebook Test. And since we're going to be having our main method, in this class, we're going to make sure that we tick public static void main, and we can press on finish. Since the gradebook class is in the same package as our gradebook test class, there's no need to import gradebook, but if it was in a different package, we would have to import it. And as we saw before when taking input, in order to use a class, we need to create an object from it. So here we're going to be creating an object. Its type is going to be gradebook, and we're going to call it myGradebook, and we're going to set it equal to new gradebook, and we're going to have an empty set of parentheses. Once we've created our object, we can access the different public methods and variables in our gradebook class. And to do that, we're going to use the name of our object, and we're going to use the dot operator. This is going to give us access to different methods. In our case, we want to use the display message method. Now, if we save our file and if we run our code, we get welcome to the gradebook. Next, we're going to see methods that take input. So we're going to go back to our gradebook class. To make our display message method more dynamic, we're going to pass in an input of type string, and we're going to give it a name. We're going to call it course name. And what we want to do is, instead of displaying welcome to the gradebook, we're going to substitute in course name. To do that, we can change our println statement to printf. And instead of gradebook, we're going to use %s, which is a placeholder for strings. And we can also add a new line character. And finally, we want to substitute in the course name in place of %s. So here we're passing course name as input, which is of type string. One thing you shouldn't forget is when we're writing string, we need to use a capital S. That is because string is a non-primitive data type. Primitive data types are the most basic data types that come with Java and include data types like float, double, int, and boolean. Once we've passed in course name to our method, we can use it throughout our method. In our case, we're using it in the printf statement. Now we can go back to our gradebook test class. As you can see, we're getting an error. That is because our display message requires an input. So we're going to give it a string input. Let's say Java programming. And now if we save our file and run our code, we get welcome to the Java programming displayed to the terminal. The exclamation mark is on the next line because we misplaced the new line character, which we can fix back in our gradebook. And we're going to move the exclamation mark before the new line character. Now if we go back to gradebook test and run our file, we get welcome to the Java programming. One more thing we can do here to make our program more dynamic is, instead of directly giving in the course name, we can take it from the user. And whenever we're dealing with user input, we need to import the scanner class. So we're going to import java.util.scanner. And again, to use this scanner class, we need to create an object of type scanner. We're going to call it input, and we're going to set it equal to new scanner system.in. Next, we're going to remove this line, and we're going to prompt the user to enter in the course name. We can do that with a print statement, and we're going to prompt them to enter the course name. And using the input object, we're going to access next line. Till now, we've been using the nextInt method that is used to get an integer input from the user. Now we're using the nextLine method, which is used to get a string input. So once we have the course name, what we can do is store it in a variable. We're going to call it name of course, and we're going to set it equal to our input statement. Finally, we're going to use our myGradebook object, and we're going to access the display message, and we're going to pass in the name of course variable. Now we can save our file and run our code. It's going to ask us to enter the course name. Let's put in C++ programming. And if we press enter, we get the message, welcome to the C++ programming. Till now, when we wanted to use the scanner class, we had to import it. But you may have noticed that we didn't have to import the system class or the string class. This is because by default, all the classes in the java.lang package are imported to our code, and system and string are part of that package. The next concept we're going to be looking at are instance variables. As we defined earlier, instance variables are attributes of our class. So we're going to go back to our gradebook.java file, and we're going to create an instance variable. So we're going to be creating instance variables inside the class, but outside of the methods. So first we need to define its access modifier. We're going to use private. Next, we need to give its data type. We're going to use string, and we're going to give it a name. So we're going to have course name. Now, since this instance variable is private, we cannot access it outside of this class. In order to access this variable, we're going to be using methods that are called getters and setters. So the get method is going to get us the value of the course name instance variable, and the set method is going to give us the option to set whatever value we want to the course name. So we're going to define the getter method first. So we're going to have public. It's going to return the course name, so the return type is going to be string, and we're going to call it get course name. It's not going to take any input, so we're going to have an empty parentheses. And inside the method, we're going to return a value. So to return a value, we're going to use the return keyword, and we're going to give it course name. One thing you need to note here is that the getter and setter methods need to be public in order for other classes to access those methods. Next, we're going to define the setter method. Again, it's going to be public. This time it's not going to return anything, so it's going to be void, and the name is going to be set course name. Now this method is going to take input, so we're going to have string, and we're going to call the input name. And inside the method, what we're going to do is set course name to the name that is given to the method. Once we've defined our getters and setters, we can also replace the course name inside our display message. So our display message no longer needs to take input. Now to get the course name, we have two options. Since we're in the same class, we can directly access course name. Another option we have is using the get method. When calling methods, one thing we shouldn't forget is we need to add parentheses. So now we can save this file, and we're going to go back to our gradebook test class. We're getting some errors. That is because the display message no longer takes in any input. Instead, what we're going to do is once we get the name of the course, we're going to be using the set method. So to do that, we're going to say mygradebook.set course name, and we're going to pass in the name of course variable. So what this is going to do is it's going to take in a string from the user, and it's going to give it to our setter method. And finally, we're going to call the display message method. Now, if we save our file and run our code and enter a course name, we can put in Java programming and press enter, we get the same message displayed. Now, to show you how access modifiers work, we're going to try to access the course name variable, which we set to private. So if we try to do that using the object, so we're going to have mygradebook dot, and if we try to access course name, we're going to get an error. That is because the course name instance variable is set to private. The final topic we're going to be looking at in this section are constructors. A constructor is a special type of method which we actually have used before, but we may have not noticed it. Constructors are used to initialize instance variables. One thing we didn't discuss about instance variables is that they have default values. So if we didn't give course name a value, its default value would be null. And for the different data types, there are different default values. So if we had an int instance variable, its default value would be 0. And for float and double, their default values are 0.0. And finally, for Boolean, its default value is false. So we use a constructor when we don't want to use those default values. And by using a constructor, we can set custom default values. So to see this, we're going to go back to our gradebook.java class. The first point we need to remember is that constructors have the same name as our class. So to define a constructor, we're going to have public. And since a constructor is a special type of method, it's not going to have any return type. It's not even going to have void. Instead, we're going to go directly to its name. And as we said, its name is going to be the same as our class name. And in parentheses, we can give it any input that we want to set to our instance variables. In our case, we're going to be using it for the course name instance variable. So we're going to have a string input, and we're going to call it n. And inside the block, we're going to set our course name variable to n. Now for more readability, we should move the instance variable to the top. Now you may be wondering what the difference is between a constructor and our setter method. The difference is that we can use the setter method whenever we want, but the constructor is going to be used immediately when we create an object. So to see that, we're going to save our file and go back to the gradebook test class. So you may be wondering when we've used a constructor before. We used a constructor when creating objects using the new keyword. For example, when we created a scanner object, here the second scanner we have is actually a call to the constructor. In our gradebook objects as well, the second gradebook we have is a call to our constructor. Another question you may have is that even though we didn't define a constructor in our gradebook, we didn't get any errors. That is because every class implicitly has a default constructor that doesn't initialize anything. But now we're getting an error. That is because we defined a constructor and we need to follow the structure of that constructor. In our case, our constructor took in a string input, so we need to define a string when we're creating the object. So we can give it a string value, let's say Java programming. And now the error disappears. So what this statement does is it's going to call our constructor and it's going to give it Java programming as input. And directly when our object is created, it's going to have a course name. So to see this, we can comment out the input from the user. And if we save our file and run our code, we get welcome to the Java programming. So here Java programming is going to act as a default value for the course name variable, but that doesn't mean that we cannot change it. To see that, we're going to uncomment our user input code, and we're going to save our file and run the code again. It's going to ask us to enter the course name. Right now the course name is set to Java programming, but if we give it a new name, let's just call it Java and press enter, the course name variable gets updated to Java. Now to really see that the default value was actually applied, what we can do is copy the default message and we're going to add it directly below the object creation. Now the display message is going to run twice. So if we save our file and if we run our code, first we're going to get welcome to the Java programming, and if we enter a new course name like Java, then we get welcome to Java. In this video, we're going to be looking at control structures. Control structures are ways we control the flow of our program. We're going to be looking at two categories of control structures: selection statements and repetition statements. Selection statements are used to make decisions in our code. If a certain condition is true, we execute one part of our code, and if it's not, we execute another part of our code. We've already seen one selection statement before, that is the if statement, and now we're going to be looking at the remaining selection statement, which is the switch statement. The switch statement has the same functionality as a series of else-if statements, so it's basically used to check multiple conditions. To see this, we're going to create a new class. We're going to call it days of the week. And since we're going to be running the program, we're going to tick public static void main. So the program that we're going to be building is going to take in a number from 1 till 7, where 1 represents Monday, 2 represents Tuesday, and so on. So our program is going to convert the number format to the word format. So if we give it 1, it's going to give us Monday. If we give it 3, it's going to give us Wednesday. First, we're going to declare a variable of type int, and it's going to be called day. So this is going to be the number format of the day. Initially, we can set it equal to 3. So our program should return Wednesday. Now, how we use switch statements is first we write switch, and in parentheses, we put in a variable name that we want to compare to different values. In our case, we want to compare the day variable, so we're going to say day. And in curly braces, we're going to have different cases. So the first case we're going to have is if day is equal to 1. So if day is equal to 1, we want to print out Monday. And then we're going to have a break statement. Later on, we're going to see why this break statement is important. Next, we're going to have case 2. And in that case, we're going to print out Tuesday. And again, we're going to have our break statement. Then we're going to have case 3. And we're going to print out Wednesday. Another break statement. Then we're going to have case 4. And we're going to print out Thursday. And another break statement. And we're going to have case 5. And we're going to print out Friday. Another break statement. Then we're going to have case 6. And we're going to print out Saturday. Another break statement, and we're going to have the final case, which is case 7. And we're going to print out Sunday. And we're going to have our break statement. Now, one more thing we can do is if there is no matching case, we can run a default case. So to do that, we're going to have default, and we're going to print out invalid day. So what is happening here is we have a day variable, and we're going to compare it to each case value. So if day is 1, we're going to execute this block of code. If day is 2, we're going to execute this block of code, and we're going to go on until day 7. And if day is a number that is not in the cases, so for example, if we had 8, then our switch statement is going to go to the default case and execute the print statement. Now to see this, we're going to save our program and run our code. As you can see, we get Wednesday displayed. If we set day to 2, for example, and save our file and run our code, we get Tuesday. If we set day to an invalid day of the week, for example, if we put in 8, if we save our file and run our code, we get invalid day. Next, we're going to see why the break statements are important. To see this, we're going to remove the break statement from case 1, and we're going to set our day variable to 1. Now, what we expect to be displayed is Monday, but if we save our file and run our code, we get both Monday and Tuesday. So if we don't put in a break statement, it's going to go to the next case and it's going to execute the statement until it reaches a break statement. So that is why it is important to include a break statement in each case. The next control structure we're going to be looking at is repetition. We use repetition when we want to repeat a certain piece of code multiple times. To see this, we're going to go back to our gradebook class, which we wrote in the previous video. So our gradebook class currently has different methods, and the last method we have is the display message method. And now we're going to add one more method. So inside our class, we're going to define public void determine class average, and we're going to have empty parentheses because our method is not going to take in any input, and we're going to have a block of code. So what this method is going to do is it's going to get different grades from the user, and it's going to calculate the average of those grades. So since we're going to be taking input, we need to have a scanner object, and we're going to call it input, and we're going to set it equal to new scanner system.in. We're getting an error here. That is because we haven't imported scanner. So we're going to import it now. So we're going to have import java.util.scanner. And we're going to go back to our method. To calculate an average, the first thing we need is going to be a total variable. And we're going to set it initially to 0. Next, we're going to have a variable called grade counter. Again, we're going to set it to 0. What this variable is going to do is it's going to count the number of grades that the user enters. And we're going to also have a variable called grade. This is going to actually store the user's input. And finally, we're going to have an average. So since average is going to be a decimal value, we're going to store it in a double called average. The next step is going to be prompting the user to enter a grade. We can do that using system.out.print, and we're going to prompt them to enter a grade or -1 to quit. So what this is going to do is it's going to tell them to enter a grade, and if they enter -1, that means they've finished entering grades, and it's going to calculate the average. And to take their input, we're going to use the input object, and we're going to have next int, and we're going to store it in the grade variable. Now, the problem with this program is it's going to only ask them to enter a grade once, but in our case, we want to ask them multiple times until they enter -1. So to accomplish this, we're going to be using what is called a while loop. So how a while loop works is we're going to have a while, and in parentheses, we're going to have a condition. If this condition is true, everything in the while loop is going to continue executing again and again. But when the condition is false, we're going to break out of the while loop. In our case, we want to continue the while loop as long as grade is not equal to -1. So in our while loop, first we're going to add whatever the user entered to our total variable. To do that, we're going to have total is equal to whatever total was previously plus the grade that the user entered. Now there's a simpler way to writing this statement. Instead of writing total twice, what we can do is remove the second total, and we can have plus equal. So this is the same statement as before. It's going to add the grade variable to the total variable. Next, once we add it to the total, we also want to update our grade counter. So to do that, we're going to have grade counter plus equal 1. Again, there's a shorthand that we can use for updating a variable by 1, and that is using plus plus. What we want to do next in our loop is ask the user to enter a grade again. So we're going to use our print statement again. We're going to prompt them to enter a grade or -1 to quit. And we're going to store their entered grade inside the grade variable. So this is going to be the end of our while loop. So as long as the user doesn't input -1, we're going to ask them to enter a grade again and again, and we're going to be adding that grade to the total and updating our grade counter. Outside our while loop, we're going to calculate the average. So we're going to have average is equal to total divided by grade counter. Here, there's one more thing we need to do. Currently, total is of type int, and grade counter is also of type int. So in Java, when you divide an integer by an integer, you're going to get an integer result. But in our case, we want average to have a decimal value. So we need to change one of our operands to double. To do that, we're going to do something called casting. We simply have a parentheses before the variable that we want to cast to a different type. In our case, we're going to cast total to double. So we're going to have parentheses, and in parentheses, we're going to type in double. And now if we divide a double by an integer, we're going to get a double result. And once we've done that, we're going to print the average out. So we're going to have system.out.printf. First, we're going to print out the total of the grades. So we're going to have total of the %d grades entered is, followed by a %d and a new line. And in the first %d, we want to substitute grade counter. And in the second %d, we want to substitute total. And finally, we're going to end our statement. Next, we're going to print out the average. So we're going to have system.out.printf. And we're going to say class average is %f. So the placeholder for a decimal value is %f. And we're going to have our new line character. And in the %f, we're going to substitute average. When displaying decimal values using printf, one thing you can do is adjust the precision. So here, if we add a .2, this is going to make sure that we only have 2 digits after the decimal place. Now we can save this file and go to our gradebook test class. And we're going to comment out the code we had previously. And we're going to create a gradebook object. We're going to call it my gradebook. And we're going to set it equal to new gradebook. And in parentheses, we have to pass in a course name. So we're going to give it Introduction to Java. Once we've created the object, we can access the determine class average method. So we're going to have my gradebook dot determine class average. Now we can save this file and run our program. It's going to ask us to enter a grade. Let's put in 98. It's going to ask us again. Let's put in 74. It's going to keep asking us until we enter -1. Let's add one more grade. Let's put in 100. Let's press enter. And to end the while loop and calculate our average, we're going to enter -1. And if we press enter, we get the total of the 3 grades and we get the class average. The remaining 2 repetition statements we're going to be looking at are for loops and do while loops. First, let's look at the for loop. We're going to create a new class and we're going to call it for loop. And since we're going to be running this class, we're going to tick public static void main and we're going to press on finish. So a for loop has the same purpose as a while loop. The difference is that we usually use a for loop when we know how many times our code is going to repeat. In our previous example, we did not know how many grades the user might enter, so we used a while loop. But we use a for loop when we know how many times our program is going to repeat. So the syntax to using a for loop is we're going to have a for, and in parentheses, first we're going to have an initializing statement. This is going to initialize a variable. So let's have int counter and we're going to set it equal to 1. So this is the initializing statement. Next, we're going to have a condition. As long as this condition is true, our for loop is going to continue. In our case, we're going to have as long as counter is less than or equal to 10. And finally, we're going to have an updating statement. This is going to update the variable inside our for loop. In our case, it's going to update the counter variable, and we're going to increase the counter variable by 1 each time the loop repeats. So this is the syntax to using a for loop. Inside our for loop, we're going to simply print out the counter variable. We can do that using a printf statement. So we're going to have %d space, and in the %d, we're going to substitute counter. Now, if we save our file and run our code, we get the numbers from 1 till 10 displayed to our terminal. The final repetition statement we're going to be looking at is a do while loop. So we're going to create a new class and we're going to call it do while. And since it's going to be executed, we're going to tick public static void main and we're going to press on finish. A do-while loop is similar to the other repetition statements. What makes it different is that at least it's going to run once, whether or not the condition is false. So to see how a do-while loop is written, we're going to have a counter, and we're going to set it to 1, and we're going to have do, and in curly braces, we're going to have a block of code. In our case, we're going to print out the counter variable. And we're going to update the value of our counter by 1 each time the loop repeats. And once we've finished writing our block of code, we're going to have while, and in parentheses, we're going to have our condition. In our case, we're going to have while counter is less than or equal to 10. So this is going to execute the same as our for loop. The difference between a normal while loop and a do-while loop is that in a do-while loop, we first execute the statements. Then after are we going to check the condition inside the while loop. But when we are using a normal while loop, we're going to check the condition first, then we're going to execute the statements. So if we save this file and run our code, we get the numbers from 1 till 10. The final concept we're going to be looking at in this section are two keywords that are used to control our loops. And these keywords are break and continue. To see how these keywords work, we're going to go back to our for loop. The first keyword we're going to look at is the break keyword. So we've already seen break before when we were dealing with switch statements. And when it comes to loops, it also has the same functionality. We use the break statement when we want to exit out of our loop before the loop condition is met. So to see this inside our for loop, we're going to have an if condition. And we're going to say if counter is equal to 5, then we want to break. So what is going to happen here is counter is going to start from 1, it's going to get displayed, it's going to go all the way up to 4, and in the next iteration when counter is 5, it's going to go inside this if statement and it's going to see the break statement. And when it sees the break statement, it's going to exit out of our for loop. So the output we're going to have is the numbers from 1 till 4. So if we save our file and run our code, we get the numbers 1, 2, 3, and 4. The next keyword is the continue keyword. We use the continue keyword when we want to skip the current iteration or the current repetition. So if we go to our if statement and if we change the break statement to a continue, what is going to happen here is the numbers from 1 till 4 get printed out, and when counter is equal to 5, it's going to skip the current iteration. That means 5 is now going to get printed out, and it's going to go to the next iteration, and counter becomes 6. So what this is going to do is it's going to print the numbers from 1 till 4, it's going to skip 5, and it's going to print the numbers from 6 till 10. So if we save our file and run our code, we get the numbers from 1 till 10, excluding 5. And in this video, we're going to be looking at methods in more depth. As we said before, methods are blocks of code that perform a specific task. These methods can take input, and we call these inputs the parameters of the method, and they can also return a certain type of value. When a method performs a task that does not depend on the contents of any object, we declare that method as static, and we call it a static method or a class method. So the difference between a static and a non-static method is that to call a non-static method, we need to first create an object and use that object variable to call the method. But when it comes to static methods, since they do not depend on objects, there is no need to create an object, so we can simply use the name of our class to access the static method. An example of a built-in class that has static methods is the math class. To see that, we're going to create a new class, and we're going to call it math methods. And since we're going to be running the class, we're going to tick public static void main, and we're going to press on finish. Now to use the math class, we do not need to import it. That is because it's part of the java.lang package, and as we've seen before, All the classes in the java.lang package are imported by default. In our main method, we're going to declare an integer variable called num, and we're going to give it the value 4. And what this program is going to do is it's going to print out the square of this number and the square root of this number. So we're going to have system.out.printf, and our format is going to be the square of %d is %f, followed by a new line character. So in the %d, we're going to substitute num, and in the %f, we're going to substitute the square of 4, which we can calculate using the math class. So we're going to have math dot, and the name of the method is POW, which is going to take in 2 inputs. The first number is going to be the base, and the second number is going to be the exponent. In our case, since we want to square the number, our exponent is going to be 2, and we're going to end our statement. So what we need to note here is that in order to use the POW method, we did not create an object. Instead, we directly used the method using the class name. So what this means is the POW method is a static method. You can also have another print statement. And this time our format is going to be the square root of %d is %f. And we're going to have our new line character. And the %d, we're going to substitute num. And to calculate the square root, again, we can use a static method inside the math class. So we're going to have math dot, and the method name is sqrt, and it's going to take in 1 input. One thing to note here is that both math.pow and math.squareroot return floating point numbers or decimal numbers. So when we use a printf statement for the placeholder, we're going to have to use %f. Now we can save our file and run our code, and we get the square of 4 is 16 and the square root of 4 is 2. Another concept we can look at is static attributes. Just like static methods, we can also have static attributes. To see this, we're going to create a variable of type double, and we're going to call it area, and we're going to set it equal to num times, and we're going to use a static attribute in the math class, which is math.pi. So here, since we're not creating an object to access the value of pi, this means that pi is a static attribute. So to see that this works, we're going to have a print statement. Our format is going to be the area of a circle with radius %d is %f followed by a new line. For the %d, we're going to substitute num, and for the %f, we're going to substitute area. So if we save our file and run our code, we get the area of a circle with radius 4 is 50.26. So from what we've seen so far, we can now explain why the main method is static. Declaring main as static allows the JVM to invoke the main method without creating an instance of our class or without creating an object. Next, we're going to look at the random class, which has different methods for generating random integers, doubles, or Boolean values. To see this, we're going to create a new class, and we're going to call it roll dice. And since we're going to be running this program, we're going to tick public static void main. Now, since the random class is not part of the java.lang package, we're going to have to import it. So we're going to have import java.util.random. And to use the random class, we're going to create an object. It's going to be of type random, and we're going to call it random numbers, and we're going to set it equal to new random. Now what our program is going to do is it's going to simulate rolling a dice 6,000 times, and it's going to tell us the frequency of each number. So it's going to tell us how many times we got 1, 2, 3, 4, 5, or 6. So to store these frequencies, we're going to have variables. The first one is going to be called frequency 1, and we're going to set it to 0. We're also going to have frequency 2, and we're going to set it to 0. Frequency 3, and we're going to set it to 0. Frequency 4, and we're going to set it to 0. Frequency 5, and we're going to set it to 0. And finally, we're going to have frequency 6, and we're going to set it to 0. Next, we're going to have a variable called face. This variable is going to store whatever number we get when we roll the dice. Now, to roll the dice 6,000 times, we need to use a loop. And since we know how many times our loop is going to run, we're going to use a for loop. And our initializing statement is going to be int roll is equals to 1. Our condition is going to be roll is less than or equals to 6,000. And our updating statement is going to be roll plus plus. So inside our for loop, we're going to generate a random number. To do that, we're going to have our random numbers object, and we're going to access the next int variable, which is going to take in a bound. In our case, we're going to give it 6. So what this is going to do is generate a number from 0 to 6 without including 6. So it's going to generate a random number from 0 to 5. But when rolling a dice, we want to generate a number from 1 till 6. So what we can do is add 1 to this statement. So what this is going to do is generate a number from 1 till 6. Finally, we can set this statement to face. And to check what number we got, we can use a switch statement. So we're going to have switch. The variable we want to compare is face. And we're going to have our different cases. So the first case is 1. So if our face is 1, we want to increase the frequency for 1. And we're going to have our break statement. Our second case is 2, and we're going to increase the frequency for 2, and we're going to have break. Then we're going to have case 3, and we're going to increase the frequency for 3. Then we're going to have break. Then we're going to have case 4, and we're going to increase the frequency for 4. Then we're going to have break. We're going to have case 5. We're going to increase the frequency for 5. We're going to have break. And finally, we're going to have case 6. And we're going to increase the frequency for 6. And we're going to have a break. Next, we're going to exit out of the for loop. And we're going to print out our different frequencies. So we're going to have system.out.println 1. And we're going to concatenate the frequency for 1. And we're going to copy this statement 6 more times. And we're going to save our file and run our code. As you can see, we get the frequency for each dice roll. So we've had 1 1,000 times, 2 also 1,000 times, we had 3 993 times, and so on. Now in this example, we wanted to generate a random integer, but if we wanted to generate a random floating value or a random Boolean value, we can use different methods. The final topic we're going to be looking at in this section is method overloading. Method overloading occurs when we have methods with the same name, but different sets of parameters or inputs. So the compiler chooses the right method based on the input we give it. For example, if we have 2 overloaded methods, one that takes in an int and another that takes a double, when we call this method, if we give it an int, the int method is called, and if we give it a double, the double method is called. To see this, we're going to create a new class, and we're going to call it method overload, and we won't be running this file directly, so we don't need to tick public static void main, and we're going to press on finish. So we're going to define a public method. The first method is going to have a return type of int, and it's going to be called square, and it's going to take in an integer as input. We're going to call it int num, and inside this method we're going to first print out called with int argument, and we're going to return num times num. So this is going to be our first method, and next we're going to define another public method. Its return type is going to be double, its name is going to be the same as the previous one, so it's going to be square. And this time it's going to take in a double input. We're going to call it num. And in this method, we're going to print out called with double argument. And we're going to return num times num. So this is what we mean by method overloading. One thing you need to note is that the parameter set has to be different. So what we cannot do here is have the same parameter set, but have a different return type. This is not going to work. For method overloading to work, we're going to have different set of parameters. So we're going to put this back to double, and we're going to save this file. And in order to test this, we're going to create a new class. We're going to call it method overload test. And since we're going to be running this program, we're going to take public static void main, and we're going to click on finish. Now in the main method, we're going to create an object of type method overload, and we're going to call it mn, and we're going to set it equal to new method overload. Now we don't have to import this class because they're in the same package. And now we're going to call mn.square. And first we're going to give it an int value. Let's give it, for example, 2. And since the method has a return type, we can print it out. So we're going to have system.out.println. And we're going to have mn.square. Now if we save our file and run our code, you can see that we called the method with the int argument because it gets displayed, and we also get the square. Now instead of 2, if we had 2.2, for example, a double value, and if we save our file and run our code, this time we're calling the double method, and we're going to get a double value returned. And in this video, we're going to be looking at arrays and array lists. When we want to store a collection of related data types, we use arrays. So arrays are a collection of values of the same type. And to access elements of an array, we use the element's index. An index is a number that starts from 0 and goes up to the end of our array. Now, since indexes starts from 0, the first element in our array is going to be located at index 0. Now to see arrays, we're going to create a new class. We're going to call it SumArray. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. Creating an array is similar to creating an object. So the first thing we're going to have is the data type of our collection. In our case, we're going to use int. Then to differentiate arrays from other data types, we're going to have square brackets. Then we're going to give our array a name. In our case, we're simply going to call it array. And we're going to have an equal sign, and we're going to have the new keyword, followed by the data type again. And in square brackets, we provide the number of elements we want to store in our collection. So we can have 10 here. So this is going to be an array of integers that is going to store 10 values. To insert in elements, we're going to have the name of the array. And in square brackets, we're going to give the index where we want to store our data. So if we want to store it at the first position, we're going to have 0. And we're going to have an equal sign, and we're going to give it an integer value, for example, 12. So this is one way of declaring an array and adding in elements. So we're going to comment this out, and we're going to see the second method. So if we already know the elements that we want to store in our array beforehand, we can use a different syntax. So we're going to have the data type, which is going to be integer, and we're going to call it array. And we're going to have an equal sign, and we're going to have curly braces. And inside these curly braces, we're going to put in the elements that we want to store in our array. Now the program that we're going to be building is going to calculate the total or the sum of the elements inside our array. So we're going to have a total variable, and we're going to initialize it to 0. Now to go through our element, we're going to use a for loop. our initializing statement is going to be int I is equal to 0. This is because indexes start from 0, and our condition is going to be while I is less than array dot length. So as we said, arrays are like objects, and like objects, they have different attributes and methods that we can access. So in this case, we're accessing the length attribute, which is going to give us the length of our array. And since we're going to be starting from 0, we're not going to include the array length in our condition. So we're going to have less than instead of less than or equal to. And finally, our updating statement is going to be I++. Now inside our for loop, we're going to have total plus equals array, and in square brackets, we're going to give it I. So what's going to happen here is in the first iteration, it's going to access the first element of array, and it's going to add it to our total. It's going to do this until it gets to the end of our array, and it's going to add it to the total. Finally, we can print out our total using system.out.printf. Our format is going to be total of array elements %d, new line, and in the %d, we're going to substitute total. Now if we save our file and run our code, we get the total of array elements is 849. Now it's okay to use this type of for loop to access the elements of our array, but there is a special type of for loop that we can use, which is called an enhanced for loop. So we're going to have for, and in parentheses we're going to have a temporary variable that is going to store the elements of our array, and after a colon we're going to have the name of our array. And inside the for loop we can have total plus equals element. So this element variable is going to store each element in our array. So in the first iteration, it's going to have 87. In the second iteration, it's going to have 68. And it's going to go on until the end of our array. So now if we save our file and run the code, we get the same output. The arrays we've seen so far are one-dimensional arrays, but in Java, we can also have multi-dimensional arrays. For example, if we wanted to represent a table or a matrix in our code, we would use a 2D array. So to see this, we're going to create a new class, and we're going to call it 2D array. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. So the syntax to declaring a 2D array is similar to a 1D array. We're going to have the data type. Then instead of having one set of square brackets, we're going to have two sets of square brackets. Then we're going to give our 2D array a name. We're going to call it array, and we're going to set it equal to new int, and in square brackets we're going to define the number of rows and the number of columns we want. So for example, if we had 3 and 4, this means that our 2D array is going to have 3 rows and 4 columns, and in total it's going to be able to store 12 elements. And again, to access the elements, we're going to use indexes. So when we use 0, 0, we're going to the first row and the first column. And to give it a value, we're going to have the same statement as before. So we're going to have an equal sign, and we're going to give it a value. Just like 1D arrays, we can also define 2D arrays using a different syntax. So if we already know the elements that we're going to store in the 2D array, we're going to have int, then a set of 2 square brackets, then the array name, then we're going to have an equal sign, and we're going to have curly braces inside curly braces. So inside the curly brace, we can have 87, 68, 94. So this is going to represent one row. So we can have another set of curly braces, and we can define other elements in the second row. And finally, we're going to add one more row. Again, this program is going to calculate the total of the elements in our array. So we're going to have int total, and we're going to set it equal to 0. To access every element of the array, again, we're going to use a for loop. So we're going to have for, and our initializing condition is going to be int row is equal to 0. And our condition is going to be row less than array.length. And we're going to update our row variable. So this is going to go through the number of rows. So here array.length is going to be 3 since we have 3 rows. And once we have access to the rows, we need to access each element in each column. And to do that, we're going to need another for loop. So we're going to have another for loop. The initializing statement is going to be int column in is equal to 0. And our condition this time is going to be call is less than array at row dot length. And we're going to update the call variable. So what's happening here is array at row is going to give us an individual row. So in this case, if we get the first row, we're going to get a length of 3. If we get the second row, we're going to get a length of 3. And for the final row, we're going to get a length of 4. Now we can go inside our nested for loop and we're going to access array at index row and at index column. So this is going to give us each element in our 2D array. And once we have the element, we're going to add it to our total. And finally, outside the for loops, we're going to display our total variable. So we're going to have system.out.printf total, and we're going to have %d, and we're going to substitute the total variable. Now if we save our file and run our code, we get the total, which is 849. Now to make the concepts of arrays more clear, we're going to implement arrays into our gradebook class and add some more functionalities. In our gradebook class, we're going to remove the determine class average method. And we're going to define a new instance variable, which is going to have an access modifier of private, and its type is going to be int, and a set of 2 square brackets. So it's going to be a 2D array, and we're going to call it grades. And in our constructor, we're going to have an input, an additional input, which is going to be int square brackets, and we're going to call it grades array. And we're going to set our grades instance variable to the grades array that gets inputted when we create an object. Next, we're going to go to the end of our class and we're going to define a new method. It's going to be a public method and its return type is going to be void, and it's going to be called process grades. And inside this method, we're going to call another method called output grades, which we have not defined yet, but we're going to define. And we're also going to have a print statement, which is going to print out the lowest grade. So we're going to have %d and the highest grade. And we're going to have another %d followed by a new line character. And inside the first %d, we're going to call another method, which we have not defined yet, which is get minimum. And in the second %d, we're going to have get maximum, which we also have not defined yet. So the first method we're going to define is the get minimum method. So it's going to be public. Its return type is going to be int, and it's going to be called get minimum. And it's not going to take any input. So inside this method, we're going to calculate the minimum grade. To do that, we're going to first declare a variable called lowest grade, and we're going to set it equal to the first grade we have. Now to access the first grade we have, we're going to use grades at index 0 and at index 0. So this is going to give us the first grade. Now once we've set the lowest grade, we're going to go through the remaining grades, and if we get a grade that is lower than our lowest grade, we're going to update the lowest grade variable. So to access each element of our 2D array, we're going to use for loops. Another concept we didn't see in the previous file is that we can use enhanced for loops for 2D arrays as well. So we're going to have for. So our temporary variable is going to be a 1D array, and we're going to call it student grades. And we're going to access the grades 2D array. And inside this for loop, we're going to have another for loop. And our temporary variable is going to be int grade. And we're going to be accessing the student grades. So what's happening here is student grades is going to represent one row, and int grade is going to represent each individual grade inside our student grades array. Inside our nested for loop, we're going to have an if statement, and the condition is if the grade we're looking at currently is less than our lowest grade, then we're going to update our lowest grade variable to the current grade. And finally, outside our nested for loop, we're going to return lowest grade. The next method we're going to define is the getMaximum method. So it's going to be public, its return type is going to be int, and its name is getMaximum, and it's not going to take in any input. Similar to the getMinimum method, we're going to have an int called highest grade, and we're going to initially set it to the first grade we have. And we're going to have our nested for loop, which is similar to the one we had previously. So we're going to have student grades, and we're going to access the grades 2D array. And we're going to have another for loop, and we're going to have int grade, and we're going to access student grades. And inside the nested for loop, we're going to have an if condition, and we're going to check if the current grade we have is greater than our highest grade. And if it is, we're going to update our highest grade to be equal to the current grade. And finally, outside of our for loops, we're going to return highest grade. Next, we're going to define a method that's going to calculate the average for a set of grades. So it's going to be public, it's going to return a double, and it's going to be called getAverage. And it's going to take in a 1D array as input, and we're going to call it set of grades. So it's going to calculate the average of a set of grades. First, we're going to need a total variable, which is going to be initialized to 0. And we're going to go through the set of grades array. So we're going to have int grade, and we're going to access the set of grades array, and we're going to add each grade to the total. And finally, we're going to return our total divided by the number of grades we have, which we can get using set of grades dot length. Now, since we want a double to be returned, we can cast the total to be a double. Finally, we're going to define our output grades method, which is going to be public. It's going to have a return type of void, and it's going to be called output grades. And it's not going to take in any input. First, we're going to print out the grades are followed by a new line character, and we're going to end our statement. And next, we're going to have a printf statement, and the format we're going to have is a bit more complicated than the ones we've seen before. We're going to have %10s, %10s, another %10s, another %10s, and one more %10s. So we've seen numbers between the percent and the placeholder. So we've seen it before when we were dealing with the precision of decimal values. We had 0.2. And when we have a whole number between the percent and the placeholder, it's going to define our column width. So what that means is each placeholder is going to take up 10 spaces. So we're going to have a uniform spacing. And the first %s, we're going to simply have a space. And the second %s, we're going to have test1. And the third %s, we're going to have test2. And the fourth %s, we're going to have test3. And finally, in the fifth %s, we're going to have average. And we're going to end our statement. Next, we're going to display the grades of each individual student. To do that, we're going to have a for loop. So we're going to have for int student is equal to 0. And our condition is going to be student is less than grades.length. And we're going to update our student variable. Now, there is a reason we used the traditional for loop. That is because we want to use the student variable to represent each student. So we're going to have a print statement. And our format is going to be student followed by %2d. So in the place of d, we're going to substitute the student variable, the one we have in our for loop, plus 1. So what this means is it's going to display student 1, student 2, student 3, and it's going to go on until the last student. Once we've displayed the student, next we're going to display the grade. To do that, we're going to have another for loop, and this time we're going to use the enhanced for loop. We're going to have int test, and we're going to access grades at the index student. So what this means is grades is a 2D array, and when we access grades at a specific index, we're getting a 1D array. So we're going to be accessing each element of that 1D array, and we're going to have a printf statement. And our format is going to be %10d, and we're going to substitute in test. So again, %10d means that our placeholder is going to take up 10 spaces. And finally, we need to display the average. So we're going to have double average, and we're going to set it to a call to the getAverage method. And we're going to pass it a 1D array. So if you remember, our getAverage method took in a 1D array and calculated the average of that array. So we're going to give it grades at index student. And finally, we're going to print out the average. So we're going to have %10f, and we're going to substitute in average. Now, if we go back to the top of our code, our errors should disappear. Here we're getting an error. That is because we misplaced the semicolon. So now we're going to save our file, and we're going to go to the gradebook test class, and we're going to remove everything we have in our main method. First, let's create a 2D array that stores 3 test results for different students. So we're going to have int, 2 sets of square brackets, and we're going to have grades array, and I'm going to fill out the elements of this array. Once we filled out our 2D array, we're going to create an object of type gradebook, and we're going to call it myGradebook, and we're going to set it equal to new gradebook. And now our constructor takes in 2 inputs. The first is the name of the course, which we can give Introduction to Java. And the second input is our 2D array. So we're going to give it grades array. And next, we're going to access different methods using the myGradebook object. So we're going to access display message, and we're also going to access process grades. Before we run our code, there are a couple of statements we need to fix in the gradebook class. So we're going to go back to our gradebook, and inside our output grades method, we're going to add a new line before the student number. This is going to allow each student to occupy a single line. And one more new line character we need to add is when we display the lowest and the highest grade. So we can save this file, go back to our gradebook test, and now if we run our file. So first we get the course title, then we have each test result for each student and their corresponding average, and at the end we have the lowest grade and the highest grade. The next concept we're going to be looking at is array methods. So the array class provides different static methods that we can use to manipulate our arrays. To see this, we're going to create a new class, and we're going to call it array manipulation. And since we're going to be running this class, we're going to tick public static void main, and we're going to press on finish. In order to use the different static methods, we need to import the array class. So we're going to import it now. We're going to have import java.util.arrays. Now, since we're going to be using static methods, we don't need to create an object using the arrays class. So to see the different methods, we're going to define a double array, and we're going to call it double array, and we're going to give it a set of elements. So the first static method we're going to look at is sort. So to access the sort method, we're going to have the name of the class, which is arrays. Then we're going to have dot. Then we're going to put in the method name, which is sort. So sort takes in a parameter, and this parameter is going to be an array that is going to be sorted. So we're going to pass in double array. So now to see that the sorting has been applied, we're going to use an enhanced for loop to print out the different elements. So now if we save our file and run our code, we get the different elements in sorted order. Another static method we can look at is the fill method. To see this, we're going to create an int array, and we're going to call it filled int array. And we're going to set it equal to new int, and we're going to give it a certain size. We're going to give it 10. So we've not defined any elements in our array. So in order to fill our array, we can use arrays.fill, and it's going to take in two parameters. The first is going to be the array that is going to be filled. So it's going to be filled int array. And the second argument is with what value we want to fill our array. For example, we can pass in 7. So what this method is going to do is it's going to add 7 to each index of our array. To see this, we're going to print out the different elements. So now if we save our file and run our code, we can see that 7 has been added to each index of our array. The last topic we're going to be looking at in this section is going to be array lists. The main difference between an ordinary array and an array list is that an array list is dynamic. This means that we can change its size at execution time, which we cannot do with ordinary arrays. And there are different methods that come built in with array lists, like the add method to add elements, the size method to return the number of elements, the get method to obtain an element at a specific index, the remove method to delete a specific element, and the contains method to check if an item is in an array list. So to look at array lists, we're going to create a new class, and we're going to call it array list collection. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. In order to use an array list, we're going to have to import it. So we're going to have import java.util.arraylist. And to create an array list, it's going to be similar to creating an object. We're going to have array list. And in angled brackets, we're going to have the data type. So in our case, let's say we want the data type to be string. And we're going to call this list item. And we're going to set it equal to new array list, and we're going to have an empty set of angled brackets followed by parentheses. So this is going to create an array list of type string. So to add elements to the list, we're going to have the name of the list followed by the add method, and we can give it a string. So it's going to add the string red to our list. Another way we can use the add method is by providing an index. So we can have add 0, yellow. So what this is going to do is it's going to add the string yellow at index 0. And for example's sake, we're going to add more items. Now to see the different elements, we're going to use a for loop. So we're going to have for int I is equal to 0, I is less than item dot size. So here we're going to use the size method for array lists instead of length, and we're going to increment I. And inside our for loop, we're going to have a print statement. And we're going to print out each string. So we're going to have %s followed by a space. Now to get an element at an index from a list, we're going to use the get method. And we're going to pass in I as the index. So now if we save our file and run our code, we get the different elements in our array list. Another method we can look at is the remove method. So in our case, we have 2 yellows in our list, but if we had item.remove and in parentheses if we gave it yellow. And now if we saved our file and ran our code, as you can see, the first yellow gets removed. So that is how the remove method works. It's going to delete the first occurrence of whatever value you give it. So it's going to remove the first yellow. The final method we're going to look at is the contains method. So we're going to have a print statement. And we're going to say is red in the list. And we're going to have a Boolean value. The placeholder for a Boolean value is %b. And in %b, we're going to substitute item.contains the string red. So if we save our file and run our code, we see that is red in the list is evaluated to true. That is because red is in our list. If we had an element that is not in our list, for example, purple, and if we saved our file and ran our code, we would get false. Before we end this section, one more thing to note here is, let's say you wanted to create an array list of type integer. You cannot simply pass in int for the data type. You're going to get an error. What you need to do is use the object version of int, which is integer with a capital I. So that is how you would create an array list from primitive data types. And in this video, we're going to be looking at classes and objects in more depth. The first thing we're going to do is create a new class. And we're going to call it time1. And we won't be running this program directly, so we're now going to tick public static void main, and we're going to press on finish. So we're going to be using this class to represent time, and we're going to have two different formats of displaying time. One is going to be in 24-hour format, and another is going to be in 12-hour format. So the first thing we need to do is define our instance variables. So we're going to have private int hour, private int minute, and finally private int second. The next thing we're going to do is define a setTime method that is going to take in an hour, a minute, and a second, and it's going to set it to our instance variables. So we're going to have a public method. It's not going to return anything, so we're going to have void, and we're going to call the method setTime. And as we said, it's going to take in 3 inputs. So we're going to have int h, int m, and int s. And inside our method, we're going to be using something called a ternary operator. So a ternary operator is similar to an if-else statement, and we're going to see how we can use it. The first thing we're going to set is the hour. Now here, we're going to do some validation. So we're going to check if the inputted hour is between 0 and 24. So we're going to have if h is greater than or equals to 0 and if h is less than 24. So if this condition is true, we're going to do something, and the thing we're going to do is going to be placed after the question mark. So in our case, if h is between 0 and 24, that means it's a valid hour. So we're going to set our hour instance variable to h. And if that is not the case, then the statement after the colon is going to be assigned to our hour variable. So when using the setTime method, if we enter an hour that is not valid, we're going to set our hour instance variable to 0. We're going to apply the same validation for minute and second. So we're going to have minute, and we're going to check if m is greater than or equals to 0 and m is less than 60. So if this is true, we're going to set our minute instance variable to m, and if it's not true, we're going to set it to 0. Finally, we're going to have second, and we're going to check if s is greater than or equals to 0, and if s is less than 60. So if this is true, we're going to set second to s, and if it's not true, we're going to set it to 0. Next, we're going to define the different ways we're going to print out our time. So we're going to have another method. It's going to be public, and this return type is going to be string, and we're going to call it toUniversal string. And in this method, we're going to return a string. To return a formatted string, we can use string.format. So we're going to have %02d colon %02d %02d. So the 02 between the percent and d, make sure that whatever we put in the placeholder is going to be padded with zeros and it's going to have 2 digits. So in the first %d, we're going to substitute hour. In the second one, we're going to substitute minute. And in the final one, we're going to substitute second. So this method is simply going to display our time in 24-hour format. The next method we're going to define is going to display our time in 12-hour format. So we're going to have public, its return type is going to be string, and we're going to call it toString. And inside this method, we're going to return another string format, and we're going to have %d colon 02d colon %02d. And finally, we're going to have a %s. So the first %d is going to be the hour, the second is going to be the minute, the third is going to be the second, and the %s is going to be either AM or PM. Now to calculate the time in 12-hour format, we're going to use another ternary operation. So for the hour, we're going to check if hour is equal to 0 or if hour is equal to 12. If this condition is true, we're going to set %d to 12. And if it's not true, we're going to set it to hour modulo 12. So what's happening here is, for example, if we had 13 for the hour and we wanted to convert it to the 12-hour format, we're not going to simply display 13. Instead, we're going to display 13 modulo 12, which is 1. So this is going to calculate our hour. Next, we're going to have the minute. So for the minute, there's no calculation we need to do. We're simply going to substitute minute. And for the second, we're going to do the same. And finally, for the AM and PM, we're going to check a condition. So if hour is less than 12, and if this condition is true, we're going to have AM. And if this condition is not true, then we're going to have PM. And finally, we're going to end our statement. Now, to see how this class is going to work, we're going to save this file, and we're going to create a new class, and we're going to call it time1test. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. So here we're going to create an object of type time1, and we're going to call it time. Next, we're going to access the different methods. So first, we're going to describe what we're printing out. We're going to do that using a print statement. So the first thing we're going to be printing out is the initial universal time. And we're going to have a print statement. And we're going to print out time.toUniversalString. Next, we're going to have another description, which is going to be initial standard time. And we're going to have another print statement, and we're going to call the time.toString method. So now if we save our file and run our code, we get the initial universal time as 000000, and we get the initial standard time as 12:00:00 AM. So the concept we want to see here is that instance variables have default values, and we've discussed this before. So for integers, our default value is going to be 0. So we're going to have a 0 hour, a 0 minute, and a 0 second. And when we're calling the toString method, we need to remember that we had a condition for the hour. So if the hour was 0 or 12, we wanted to display 12. In this case, the hour is 0, so 12 gets displayed. Next, we're going to use the setTime method. So we're going to have time.setTime, and we're going to pass in an hour. Let's give it 13. We're going to pass in a minute, and for the second, we're going to give it 6. And we're going to end our statement. Now we're going to copy the above print statements and we're going to paste them. And we're going to update our description to final. And now we can save our file and run our code. As you can see, our final universal time is going to be 13:27:06. And when we convert that into 12-hour format, we're going to get 1:27:06 p.m. One more thing we can see here is the toString method. So when we define a toString method in our class, it's actually a special method, which is called when we try to print out our object. So instead of calling the toString method, if we simply pass in time to a print statement, we're going to get the same as calling the toString method. So what is happening here is called method overriding, which we're going to be seeing in future videos. So now if we save our file and run our code, we're going to get the same output. One final thing we're going to see in this class is what happens when we try to access private fields. So we're going to have time.hour, and if we try to set it to, let's say, 7, and if we set time.minute to 15, and time.second to 30, and if we save our file and run our code, we're going to get an error that says the fields are not visible. So this is because we declared our instance variables private. So the concept we take away from this is that the user of our class shouldn't have access to the inner workings of our class. The only thing our client or user should see are the public methods and how to use them. So this is why we define our instance variables as private. The next topic we're going to be looking at is the this keyword. Every object can access a reference to itself with the keyword this. And to see how it works, we're going to create a new class. And we're going to call it this test. And since we're going to be running this class, we're going to take public static void main, and we're going to press on finish. Outside of our this test class, we're going to define another class called simple time. So this is also going to be used to represent the time. So we're going to have private int hour, private int minute, and private int second. Next, we're going to initialize these instance variables, and we're going to be using the constructor. So we're going to have public, and the constructor is going to have the same name as our class. So we're going to have simple time, and we're going to pass in the inputs we want to store in our instance variables. So to see how to use the keyword this, we're going to give the inputs the same name as our instance variables. So we're going to have int hour, int minute, and int second. So one question you may have here is if we set hour to hour, how would the compiler be able to tell the difference between the instance variable hour and the input hour? When this kind of problem arises, we can use the keyword this. So when we use this, we're referring to the current object. So if we had this.hour, then we're referring to the instance variable hour. So we can do the same for minute, and we can do the same for second. So we use the this keyword when we have some sort of overshadowing, when one variable overshadows another variable. And by using this, we can refer to the object itself. And for completion's sake, we're going to define a method that is going to return a string, and it's going to be called toUniversal string. And it's simply going to return a formatted string with the format %0 to d colon %0 to d colon %0 to d. Now we can use the this keyword outside of our constructor as well. So in this method, we can access this.hour, this.minute, and this.second. So this is going to work fine, but since we don't have any sort of overshadowing, the this keyword here is redundant, so we can remove it. And to see that all this code works, we're going to go to our main method, and we're going to create an object of simple time, and we're going to call it time, and we're going to set it equal to new simple time, and since we have a constructor, we need to provide values. We're going to give it 15, 30, and 19. And we're going to have our print statement. And we're going to pass in time.toUniversalString. So we can save our file and run our code. And as you can see, the time gets displayed. In previous videos, we've seen that we can have overloaded methods, but in Java, we can also have overloaded constructors. So an overloaded constructor enables our object to be initialized in different ways. And to overload a constructor, we simply provide multiple constructors with different parameter lists. And when we say different parameter lists, we mean that the number of parameters should be different, or the order of the parameter types should be different. So to see this, we're going to create a new class. And we're going to call it time2. And we won't be running this class directly, so we're now going to tick public static void main, and we're going to press on finish. We're going to have 3 instance variables. The first is going to be hour, the second is going to be minute, and the third is going to be second. Next, we're going to define our constructors. The first constructor we're going to have is going to take in an hour, a minute, and a second. And it's going to initialize our instance variables. Next, we're going to overload this constructor. So we're going to have another public constructor. It's going to have the same name. And this time, it's only going to take in an hour and a minute. And what this constructor is going to do is, this isn't required, but this is one important concept you need to know. From a constructor, you can call another constructor, and to do that, we're going to use the this keyword, and we're going to pass in the hour, the minute, and for the second, we're going to pass in 0. So what's happening here is when we create an object, if we only provide the hour and the minute, this constructor is going to call the constructor we defined first, and it's going to give it the hour, the minute, and for the second, it's going to give it 0. Next, we're going to add one more constructor, and this one is only going to take in an hour, and it's going to call the first constructor, and it's going to give it the hour, and for the minute and the second, it's going to give it zeros. If we want to validate the hour, the minute, and the second, what we can do is go to our first constructor, and instead of setting hour directly, we're going to call a method that we haven't defined yet, which is going to be called setHour, and we're going to give it h. And for the minute, we're going to have setMinute, and we're going to give it m. And for the second, we're going to have setSecond, and we're going to give it s. Now we're going to define these methods. So we're going to have public void setHour, which is going to take in an integer as input, and it's going to set our hour instance variable to a condition. So we're going to have if h is greater than or equals to 0, and if h is less than 24, then we're going to set our instance variable to h. If that is not the case, we're going to set it to 0, and we're done with this method. Next, we're going to have public void set minute, which is going to take in a minute as input, and it's going to set our minute variable to the condition if m is greater than or equal to 0, and if m is less than 60, we're going to give it our input m. If that is not the case, we're going to give it 0, and we're going to define our final set method. So it's going to be public void set second. It's going to take in a second as input, and it's going to set our second instance variable to the condition s is greater than or equal to 0, and s is less than 60. If that is the case, we're going to take in the input, and if that is not true, we're going to pass in 0. We're also going to define some getter methods. So we're going to have public int get hour, which is simply going to return the hour instance variable. We're going to have public int get minute, which is going to return our minute variable. And finally, we're going to have public int get second, which is going to return our second variable. Now finally, as we did before, we're going to have two methods that are going to display our time in 24-hour format and in 12-hour format. So we're going to have public string, and we're going to call it toUniversal string, and it's going to return a string format. The format is going to be %02D, %02D, %02D. And now since we've defined getter methods, we can use them here as well. So we can have get hour, get minute, and get second. And we can finish our method. Next, we're going to define the 12-hour format. So it's going to be public string. It's going to be called toString. And as we said before, this is a special method, and it's going to be called when we try to print our object. So inside this method, we're going to return a string format, and the format is going to be %D, %02D, %02D. And for the hour, we're going to have a condition. So we're going to check if get hour is equal to 0 or if get hour is equal to 12. If that is the case, then we're going to set our hour to 12. If that is not the case, we're going to set our hour to get hour modulo 12. So this is going to set our hour. Next, we're going to have our minutes, so we can pass in the get minute method. And for the second, we can pass in the get second method. So that is it for our class. We're going to save this file. And to run it, we're going to create a new class. We're going to call it time2test. And since we're going to be running this program, we're going to take public static void main, and we're going to press on finish. In our method, we're going to create different objects of type time2. So we're going to have time2. We're going to call the first one t1, and we're going to have new time2 and empty parentheses. So this is going to call the constructor that takes in no input, which we actually forgot to define. So we're going to go back to our class, and we're going to define this constructor. So it's going to be public time2. It's not going to take in any input, and it's going to call another constructor, and it's going to pass in all zeros. So we can save this file and go back to our main method. So this is going to create a time object, and it's going to set the hour, minute, second to 0. We're going to have another object, t2, and this time we're going to be calling another constructor. So we're going to give it 2. So this constructor only takes in the hour, and it's going to set our minute and second to 0. We're going to create a third object, and this is going to take in 2 inputs. So it's going to take in the hour, which we can give it 21, and it's going to take in the minute. We're going to give it 34, and it's going to automatically set our second to 0. Next, we're going to have t4, which is going to call the constructor with all 3 inputs. So we're going to have 12, 25, and 42. Another type of constructor we can add is a constructor that takes in the object itself. To see that, we're going to go back to the class, and we're going to define another constructor, and it's going to take in an input of type time2. We're going to call it t. And what this constructor is going to do is it's going to copy the hour, the minute, and the second from our t input, and it's going to set it equal to our current object. So we're going to call the constructor with all 3 inputs, and we're going to give it t.getHour, t.getMinute, and t.getSecond. So this constructor is going to take in a time as input, and it's going to copy the hour, minute, and second values to the object we create. So we can save this file and go back to our main method. And we're going to create one more time object called t5, and we're going to give it t4 as input. So what this is going to do is it's going to copy the hour, the minute, and the second from T4, and it's going to give it to the T5 object. Now to see that the overloaded constructors work, we're going to have a series of print statements. So we're going to have system.out.println, and we're going to pass in T1. We can copy this line, and we're going to pass in T2, T3, T4, and T5. So now if we save our file and run our code, so for the first one, we gave it no input, so it's going to have an hour of 0, a minute of 0, and a second of 0. In this case, we're getting 12 because we're converting it to a 12-hour format. And the second object, we gave it an hour of 2, and the minute and seconds were set to 0. And the third object, we gave it a minute and an hour, and the second was set to 0. And in the fourth object, we gave it all 3 values. And finally, in the fifth object, we gave it another object to copy from, so it's going to have the same time. The final concept we're going to be looking at in this section is a composition. A composition is when a class has an object of other classes as its member. To see this, we're going to create a new class, and we're going to call it date. We're not going to be running this class, so we're not going to tick public static void main, and we're going to press on finish. This class is simply going to display a date, so we're going to have a private instance variable for the month, a private instance variable for the day, and a private instance variable for the year. And we're going to have a constructor, and it's going to take in a month, a day, and a year as input, and it's going to set our instance variables to those inputs. And finally, we're going to have a toString method. So we're going to have public string toString, and we're going to return a string format. And the format is going to be %d space %d space %d. And we're going to substitute month, day, and year. Again, one thing you shouldn't forget is the toString method is a special method. And if we try to print an object of type date, then we're going to be calling this method. Next, we're going to be creating another class. We're going to call it employee, and we won't be running this class as well, so we won't tick public static void main, and we're going to press on finish. So this class is going to represent an employee. So we're going to have a variable of type string, and it's going to be first name. We're also going to have last name. Next, we're going to have a private instance variable of type date. So this is what is called a composition. A member of the class employee is going to have a type of another class. In our case, it's going to have a type of date, and we're going to call it birth date. And we're going to have another composition, and we're going to call it hire date. Next, we're going to define a constructor, and as input is going to take in first name, last name, date of birth, and date of hire. And it's going to set our instance variables. We misspelled first name, so we're going to fix that. It's going to set last name to last. It's going to set birth date to DOB, and it's going to set hire date to DOH. Finally, we're going to define a toString method, and it's going to return a string format, and the format is going to be %s, comma, %s, and it's going to have the hired date, so it's going to be hired. And we're going to have a %s placeholder followed by a new line, and we're going to have birthday and another %s and a new line. And in the first %s, we're going to substitute first name, and the second %s, we're going to substitute last name, and in the third %s, we're going to substitute hire date, As we said, the object itself is going to call the toString method, so we're going to store it in a string placeholder. And for the final %s, we're going to have birth date. And we're going to end our statement and save our file. We misspelled string, so we're going to fix that. And we're going to save our file. To test the employee class, we're going to create another class. We're going to call it employee test. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. In the main method, we're going to have a variable called birth of type date, and we're going to give it 7,24,1949. So this is going to represent the birth date, and we're going to have another date variable called hire, and we're going to give it 3/12/1988. So we have our date variables. Next, we're going to create an employee object. So we're going to have employee. We're going to call it E, and we're going to set it equal to new employee. For the first name, we're going to give it John. For the last name, we're going to give it Smith. For the date of birth, we're going to give it birth. And for the date of hire, we're going to give it hire. And we're going to end our statement. Finally, to call the toString method of our employee class, we can simply print out the employee object. So now if we save our file and if we run our code, we get the name of our employee followed by the date they were hired and the day they were born. And in this video, we're going to be looking at inheritance. Inheritance is a form of software reuse in which a new class is created by absorbing an existing class's members. The existing class is called the superclass, and the new class is called the subclass. The subclass has behaviors of the superclass and can also add its own specific functionalities. We can have two types of superclass relations. The first is a direct superclass, which is the class that the subclass directly inherits. The second is an indirect superclass, which is any class that is above the direct superclass. So for example, let's say we have three classes, animal, mammal, and dog. Here, animal is going to be on top, mammal is going to inherit from animal, and dog is going to inherit from mammal. So relative to the dog class, mammal is its direct superclass, and animal is its indirect superclass. When dealing with inheritance, there is one more access modifier we can see, which is the protected access modifier. The protected access modifier is between public and private. When we declare a superclass member as protected, it can be accessed by members of that superclass and by members of its subclass. One thing to note here is that we can override methods in the superclass in our subclass. For example, if we had a superclass animal that has a method called sound, which prints out this animal makes a sound, we can override this method in our dog subclass to print out bark instead. Here, if we want to access the sound method in our superclass animal from the subclass dog, we can use the keyword super followed by a dot and the name of the method we want to use. Now, to see the concept of inheritance, we're going to be creating two types of employees. The first is going to be a commission employee who is paid a percentage of their sales. The second is going to be a base salaried commission employee who is paid a percentage of their sales, the same as a commission employee, but they also have a base salary added on. So first, we're going to create the commission employee class. Since we won't be running this class directly, we're now going to tick public static void main, and we're going to press on finish. Our commission employee is going to have several instance variables. Since we want to access these instance variables from our subclass, we're going to use the new access modifier, which is protected. And we're going to have a string for first name. We're going to have our second instance variable, which is going to be for last name. Next, we're going to have a string for social security. We're also going to have one that is going to store the gross salary. And finally, since this is a commissioned employee, we're going to have a double instance variable for commission rate. Next, we're going to define a constructor. So it's going to have the same name as our class. And it's going to take in inputs. The first is going to be for the first name, and for the last name, and for the social security number, for the gross salary, and finally for the commission rate. And inside our constructor, we're going to initialize our instance variables. So we're going to have first name is equal to first, last name is equal to last, social security number is equal to SSN, gross salary is equal to gross, and finally commission rate is equal to CR. Once we've defined our constructor, we're going to define a series of getter and setter methods. If you're using Eclipse, you can use this shortcut to create getter and setter methods. So what you can do is go to source, and we're going to choose generate getters and setters, and you're going to choose the properties or the attributes that you want to create getters and setters for. In our case, we're going to create it for all attributes. So we're going to select all, and we're going to click on generate. So as you can see, this is going to generate a set of getter and setter methods for each attribute. Next, we're going to define a public method that is going to calculate the earnings of this employee and return the value. So its return type is going to be double, and we're going to call it earnings. It's not going to take in any input, and it's simply going to return the commission rate multiplied by the gross salary. We've actually been writing gross salary instead of gross sales. So an easy way to replace this is going to be going to the search, and we're going to pick file, and we're going to put in the text that we want to replace, which in our case is gross salary. And for the scope, we're going to pick files opened in our editor, and we're going to press on replace. So this is going to find all the matches for gross salary, and we want to replace it with gross sales, and we can press on OK. Now back in our earnings method, we're going to return the commission rate multiplied by the gross sales. We can get the commission rate using its getter method. So we're going to have get commission rate, which we're going to multiply by the gross sales, which we can also get using its getter method. So we're going to have get gross sales. The G is actually small. And finally, we're going to define a toString method. So we're going to have public string toString, and we're going to return a string format. And the format is going to be %s, %s, space, %s followed by a new line, %s, %s, followed by another new line, %s, %.2f, followed by a new line, %s, %.2f. And for the first %s, we're going to substitute commission employee. For the second %s, we're going to substitute in the first name, which we can get using the getter method. So we're going to have get first name, and next we're going to have get last name. Next, we're going to have social security number, and we're going to use the getter method for social security. So we're going to have get social security number. Then we're going to have the string gross sales, followed by get gross sales. And finally, we're going to have commission rate, and we're going to substitute in get commission rate. Again, the method for get gross sales uses a small g, so we're going to fix that, and we're going to end our statement. So this is going to be our super class, and we're going to have another class called base plus commission employees, and it's going to inherit from this class. So we're going to save this class, and we're going to create a new class, and we're going to call it base plus commission employee. And we won't be running this class directly, so we're not going to tick public static void main, and we're going to press on finish. So as we said, this class is going to inherit from the commission employee, and to inherit from another class, we're going to use the keyword extends. So in our class declaration, we're going to have extends, and we're going to put in the name of the superclass, which in our case is commission employee. Next, we're going to define an attribute that is specific to a base plus commission employee, which is going to be base salary. So we're going to have private double base salary. We don't need to define the other attributes of an employee. That is because we've already defined them in the commission employee. And when we inherit from that class, we get all the attributes. Next, we're going to define our constructor. So we're going to have public base plus commission employee. And as input, it's going to take in all the attributes that an employee is going to have. So it's going to take in first name, last name, social security number, and so on. So we're going to have string first, string last, string SSN, double sales, double CR, and finally specific to the base plus commission employee, it's going to have double base salary. So now we're currently getting an error, and if we hover over our constructor, we see that we have to explicitly invoke another constructor, and that constructor is the one inside our superclass. So to call the constructor in our superclass, we're going to use the keyword super, and we're going to pass in the different attributes. So what this statement is going to do is when we create an object using this class and we pass in the first name, last name, and so on, it's going to take those inputs and it's going to give it to the superclass constructor, and the superclass constructor is going to initialize the different attributes. Finally, for the base salary, we're going to have another statement since it's unique to the base plus commission employee. So we're going to have base salary is equal to salary. Next, we're going to define a getter and setter method for the base salary. Again, we can do that using the shortcut we saw previously. So we're going to go to source. We're going to go to generate getters and setters. And we're going to pick base salary. And we're going to click on generate. Next, we're going to override the earnings method inside the superclass. Inside the superclass, we calculated earnings by multiplying commission rate by the gross sales. But for the base plus commission employee, we need to add the base salary. So an overridden method is a method with the same name and the same parameter list and return type, but its implementation is different. So we're going to have the same public double earnings method. And inside, we're going to change its implementation. So we're going to return. As we said, we need to add the base salary. So we're going to get the base salary using the getter method. So we're going to have get base salary. And we want to add the earnings that we calculated in the superclass. And to access that method, what we can do is have a plus. Then we're going to use the super keyword followed by a dot. Then we're going to call the earnings method. So what this is going to do is it's going to call the earnings method, which is going to multiply the commission rate by the gross sales. And to the result, we're going to add our base salary. Finally, we're going to define our toString method. So we're going to have public string toString. Now, since this method is the same as the one we have in our superclass, what we're doing here is going to be called overriding the method. So inside our method, we're going to have a return statement, and we're going to return a string format. And we're going to have %s followed by a new line, %s, %s, colon, %.2f. In the first %s, we're going to substitute the toString method that we had in our super class. And to access that, as we did before, we're going to use the super keyword, and we're going to call the toString method. Next, we're going to add the attribute that we did not have in the super class, which is the base salary. And we're going to get the base salary using the getter method. And we're going to end our statement. So this method is going to call the toString method in our super class, which is going to print out the first name, last name, and so on. And at the end, we're going to add the base salary. Finally, to test these classes, we're going to create a new class. And we're going to call it Commission Employee Test. And since we're going to be running this method, we're going to tick public static void main, and we're going to press on finish. First, we're going to create an employee of type commission employee. So we're going to have commission employee, and we're going to call it employee1. And we're going to set it to new commission employee, and we're going to give it different attributes. Next, we're going to define a base plus commission employee. So we're going to have base plus commission employee, and we're going to call it employee2. And we're going to set it equal to new base plus commission employee, and we're going to give it the same attributes as our commission employee, and we're going to add an additional base salary. Next, we're going to have different descriptions. So first, we're going to print out the employee's name. So we're going to have employee full name. And we're going to call the getter methods. So we're going to have, for the first employee, we're going to have employee1.get first name and employee1.get last name. Here we forgot to add the placeholder, so we're going to add %s, followed by a space and another %s, and a new line. So this is going to display the commission employee's full name. Next, we're going to call the employee1's toString method. To do that, we can simply print out the object employee1, since the toString method is a special method and it's called every time we try to print our object. Next, we're going to display the earnings of employee1. So we're going to have system.out.printf earnings of commission employee, followed by a %f, and we're going to substitute employee1 dot earnings. We're going to add an empty print statement for more readability, and next we're going to have our description for the second employee, or the base plus commission employee. So we're going to have system.out.printf, and we're going to have employee full name, followed by a %s space %s, followed by a new line character, and we're going to substitute employee2.get first name and employee2.get last name. Then we're going to call the toString method for employee2. Again, to do that, we simply print out the object. So we're going to have println, and we're going to pass employee2. And finally, we're going to print out the earnings of the base plus commission employee. So we're going to have system.out.printf earnings of base plus commission employee. And we're going to have a %f. And we're going to call employee2.earnings. Now we can save our file and run our code. First, we get the commission employee's full name. This is due to the getter methods. Next, we display the different information about this employee using the toString method. And finally, we display this employee's earnings. And for the next employee, we're going to have his full name, followed by a call to the toString method, which additionally prints out the base salary. And finally, we have the earnings of the base plus commission employee. Before we end this section, one thing you need to notice here is that when we were calling employee2.getFirstName and employee2.getLastName, we were able to do this even though we did not define a getFirstName and a getLastName method inside our base plus commission employee class, and that is due to the concept of inheritance. And in this video, we're going to be looking at polymorphism. The concept of polymorphism is programming in the general rather than programming in the specific. For example, if we wanted to create a program to simulate the movement of different types of animals, let's say we had a fish, a frog, and a bird, we would create a superclass called animal, which contains a method move, and each subclass will have their own implementation of the method move. So here, the method move inside the animal class refers to programming in the general sense. This means when we call the method move for each object, the compiler will know what the right thing to do is. In our example, for the fish, it would be swim, for the frog, it would be jump, and for the bird, it would be fly. Another concept we can look at is abstraction. We can have an abstract class or an abstract method. An abstract class serves as a blueprint for other classes. It can contain normal methods as well as abstract methods. An abstract method is simply a method with no body or no implementation. One thing to note here is that an abstract class cannot be instantiated on its own, which means we cannot directly create an object using an abstract class, and its main purpose is to be subclassed. A rule we have to follow is when inheriting from an abstract class, the subclass needs to implement all the abstract methods in the parent class. So if we have an abstract class animal with an abstract method move, then we would have to provide the implementation for the method move in each subclass. So to see this, we're going to create a new class, and we're going to call it animal. And we won't be running this class directly, so we won't take public static void main, and we're going to press on finish. Now this class is going to be abstract, and to declare a class abstract, we simply add the keyword abstract to the class declaration. As we previously said, we can have both normal methods and abstract methods in our abstract class. In our case, we're going to have an abstract method. So to define an abstract method, again, we're going to use the abstract keyword. Then we're going to have our method declaration, which is going to be public. Its return type is going to be void, and we're going to call it move. Now, as we said, abstract methods do not have any implementation, so we're simply going to end this statement. Next, we're going to define different classes that extend from this class. So we're going to have a class called bird, and it's going to extend from animal. As you can see, we have an error in our declaration. That is because we have to provide the implementation for the method move. So inside the bird class, we're going to have public void move, and we're going to have a print statement, which is simply going to print out fly. So now, once we've implemented the method move, our error disappears. Next, we're going to have a class called fish, which is also going to extend animal. And again, we need to implement the method move, so we're going to have public void move, and we're going to print out swim. Finally, we're going to have a class frog, which is also going to extend animal. Now, if we don't want to implement the method move in our subclass, what we can do is define the class itself as abstract. So if we change the frog class to abstract, then our error would disappear. But in our case, we want to have the implementation for the method move. So we're going to define public void move, and we're going to have our print statement, which is going to print out jump. Now we're going to save this file, and to run our program, we're going to create a new class. We're going to call it animal test. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. Now inside our method, we're going to create different objects. So we're going to have fish, and we're going to call it f. And we're going to call the move method. We're also going to have bird. We're going to call it b. And we're going to call the move method. And finally, we're going to have frog. We're going to call it fg. And we're going to call the move method. One point you need to remember here is that we cannot create objects using an abstract class. So if we try to create an object of type animal, and we called it A, then we would get an error that says cannot instantiate the type animal. So if we save our file and run our code, we get the different move methods displayed in the terminal. The final concept we're going to be looking at in this course is going to be interfaces. An interface is very similar to an abstract class, and their main difference is that abstract classes can contain normal methods, but when it comes to interfaces, they only contain abstract methods. Now, the advantage of using interfaces over classes in Java is that when using classes, we can only have a parent-child relationship, which means each subclass can only have one parent or superclass, but that is not the case when it comes to interfaces. A class can implement multiple interfaces, and instead of using the keyword extends, we use the keyword implements. Now to see this, we're going to create a new interface, and we're going to call it device, and we're going to press on finish. Now the difference in declaration between a class and an interface is that in the declaration we use the keyword interface instead of the keyword class. Now inside our interface, we're going to define different abstract methods. So we're going to have public void turn on. Again, we're not going to provide any implementation, so we're going to end our statement. We're also going to have public void turn off. And finally, we're going to have public void check status. Now you may have noticed that we did not use the keyword abstract when defining our methods. That is because since interfaces only have abstract methods, every method we add by default is going to be abstract. So we're going to save this interface, and we're going to create a new class called light. And since we won't be running this class directly, we won't tick public static void main, and we're going to press on finish. Now this class is going to implement the device interface, and as we said, we're going to use the keyword implements, and we're going to give it device. Now as soon as we implement our interface, we get an error. That is because we need to define the implementation for the different abstract methods inside our interface. Before we do that, we're going to have an instance variable of type boolean, and it's going to be called isOn, and initially it's going to be false. Next, we're going to implement our abstract methods. First, we're going to have public void turn on, and this method is going to set our instance variable to true, and it's also going to have a print statement, and it's going to print out light turned on. Next, we're going to implement the turn off method. So we're going to have public void turn off. This method is going to set the isOn attribute to false, and it's also going to have a print statement, which is going to print out light turned off. Finally, we need to implement the check status method. So we're going to have public void check status. And inside our method, we're going to have an if condition. So if the isOn attribute is true, then we're going to print out light is currently on. And if that attribute is false, we're going to print out light is currently off. So that is it for the light class. So we're going to save this file. Next, we're going to create one more class, and we're going to call it fan. And we won't be running this class directly, so we won't take public static void main. And we're going to press on finish. Again, this class is going to implement the device interface. And we're going to have our instance variable of type boolean, and it's going to be called isOn. And we're going to set it to false initially. Then we're going to implement our abstract methods. So we're going to have public void turn on, which is going to set the isOn attribute to true, and it's going to print out fan is on. Next, we're going to implement the turn off method. So we're going to have public void turn off, which is going to set is on to false, and it's going to print out fan is off. And finally, we're going to implement the check status method. So we're going to have public void check status, and we're going to have our if condition, which is going to check if isOn is true. And if it is, we're going to have a print statement, and we're going to print out fan is currently on. And if isOn is false, we're going to print out fan is currently off. So that is it for the fan class. So we're going to save this file. Now to test out the different devices, we're going to create a new class. And we're going to call it device test. And since we're going to be running this class, we're going to tick public static void main. And we're going to press on finish. In our main method, we're going to define an array of type device, and we're going to call it devices. Now here is where we can see the usefulness of polymorphism. So we can have an array of type device, which is basically the parent class for the light and fan class. So what we can do is store devices of different types in the same array. So we can have different fans and different lights in the same array of type device. In our case, we're going to set it to new light and new fan. So this is basically a shorthand, and what it's doing is it's creating an object of type light, and it's storing it in the array, and it's also creating an object of type fan and storing it in the devices array. So from what we've seen previously, we could only store one type of object inside our arrays, but by using the concept of polymorphism, we can store different types in the same array. Next, we're going to define a for loop that is going to turn on all our devices. So we're going to have for. Our temporary variable is going to be of type device, and we're going to call it device. And we're going to loop through the devices array. And for each device, we're going to call the turn on method. Next, we're going to have another for loop, which is going to go through the devices array. And this time, we're going to call the turn off method. And finally, we're going to have a third for loop, which is going to go through the devices array. And it's going to call the check status method. Now, if we save our file and run our code, we can see that the turn on method is called for both devices. Then we have the turn off method. And finally, we have the check status method. So this has been a full beginner's guide to object-oriented programming in Java. If you have any questions, you can put them in the comment section below. Thank you for watching this video, and don't forget to like the video and subscribe to our channel for more programming content.